Okay, let's have a look at some of the basic map types. Now there's obviously lots of different map types that we've got. So we've got axial, tangential again, height, refractive power and elevation. So these are the basic ones that we're going to cover. We're going to start off with the tangential plot. It's kind of the easiest one to understand. So looking at the tangential plot, which is what we've got here. Now this is quite a good cornea because it's an average cornea. We've got a little bit of irregularity, which is actually the tear film meniscus being pulled up. So that's this red here. It's not an abnormal cornea. It's just a lump and a bump. And that's what tangential is good for. So with tangential, what happens is every single measured point on the placido ring, so there's about 100 and odd thousand measured points here, is treated as an individual point, and the measurement at that one point you can see is shown down here. So at this point where the white cross is, we've got measured 8.11 millimeters, and here 8.02, here we've got 6.70. So every single point is considered as a tangent. Now what is a tangent? Well, tangent is a plane that would be perpendicular to the line surface. So the way to think about it is basically you've got a perpendicular line, a measurement coming off the cornea at exactly 90 degrees. And that's you're going to get this pinpoint measurement. So tangential is also the pinpoint measurement. So that's the tangential plot. Every point is considered regardless of anything else beside it. That differs slightly from axial. And axial, I'm going to kind of group axial and refractive power. They're just slightly different equations, but effectively it's an axial. We're assuming that every point is now going to go through the visual axis, which of course is where the patient's looking. So it puts a kind of smear, a mathematical smear over the cornea, which smooths things out. It gives us a better representation of the cornea as a lens, which of course it is, but it's less good from the point of view of seeing any detail abnormalities. And you can see that the tear film blob at the bottom of this map is harder to see. So axial is the rays of light, if you like, going through the visual axis. So there's a mathematical sphere going onto it, and that's similar to refractive. The next map to consider is the height map. Now this is really the one that the topographers are actually measuring, if you like, and height's probably best understood looking at the three-dimensional perspective view. So you can see the point right in the middle is the reference point. So the height there is 0. Topographer is always going to work from that point on the center of the map outwards. So we've got 0 height there, and then this is looking at the hill of vision going out towards the periphery and just taking a height measurement. We don't really use height, but this is the plot which is considered with elevation. So elevation is a similar plot, so it uses the height. But elevation, what we do is we put a best vision sphere onto this cornea. So this would be an 8mm spherical gas perm lens. We're going to plonk that onto this cornea. And then the elevation is the difference between that 8mm sphere and where the cornea is. So if there's a big gap, like in this blue area at the top, we've got 34 microns of clearance, then you've got a bigger gap, so there would be fluorescein pooling here. So this is the map which we use if we do a fluorescein representation on the eye. Of course, the fluorescein on the cornea doesn't represent lid interaction, and there's downsides to it, but it's the way that gas perm lenses are designed on the topography map. So that's tangential, this pinpoint map, axial and refractive, where they have this mathematical sphere on them, assuming that the cornea is a lens. And then we've got basically the elevation map is the one that's got any relevance from the height, the actual three-dimensional hill of the shape of the cornea in relation to a lens or what we're going to fit with it. So I hope you found this video useful. Check out our other videos, including the other ones in this series on topography.